Right. This is exam prep 5, the continuation of question 12. And as I say, we spent a bit too much time on it, but nevertheless, let's carry on. Hopefully we're doing it well, and you guys are getting into the recipe of doing this, okay? The next one I wanted to look at is potassium sulfate and barium nitrate. Okay, if we don't know what they look like, what do? Well, we put down, we know what potassium is, it's K. And sulfate is SO4. Remember copper sulfate, the one we use a lot, the blue one, copper sulfate. And barium nitrate, well, barium is Ba and nitrate is NO3. Okay. Then they've said, oh, it goes to question mark. You've got to put in your best guess at this one and then balance it, right? So let's see. Well, first of all, K, before we start, let's just get our baby numbers, the subscripts. Let's get those sorted out first, okay? K is +1. A sulfate ion is a -2, right? That's going to be a subscript at the bottom. Barium, all right? Barium, we say, where are you? It's in column 2, isn't it? Okay, so barium is a +2. Nitrate is a -1. So let's put in the balancing numbers before we start. We're going to have 2 potassiums to balance out that -2. Barium, we're going to have 2 of those to balance that out, right? Now, when we put this together, okay, the chances are we're going to get potassium nitrate and barium sulfate, all right? That's the best guess. Why did we say that? Because look here, positive and a negative, and over here, let's complete it. This is a plus and this is a minus. So the chances are that's going to go with that one, and yep, the other one's going to go with that one, right? Because it is a reaction, something happens. Otherwise, they wouldn't have given it to us, would they? So let's see what's going to happen, okay? We're going to have, that's going to be barium sulfate. Okay. Let's just put in where it goes, all right? Barium sulfate. So the barium, Ba, and the SO4 are going to get together, and I'm running out of space over here. I don't want to go too far to the right. So barium sulfate, and just to write underneath it, plus potassium nitrate, KNO3. And remember, before we start, we've got to put in this number. This is a -2, this is a +2. This is a +1, this is a -1. So there are no subscript numbers on that side. Then we go along and we say, right, let's look at the balancing number. Barium, over here I've got 1, there I've got 1. Potassiums, there's 2. So I've got to put in a 2 there. And now there's 2 NO3s and therefore 2 NO3s. So it is balanced. Okay? Right. Now, let's have a look at the next one. Okay? The next one, ammonium nitrate. Okay. Let me just, ammonium nitrate, ammonium, hang on, that is NH, hey, ammonia, A comes before M, 3 before 4, therefore its ammonium is NH4. And it's ammonium nitrate, NH4, NO3, okay, plus calcium hydroxide, Ca and an OH. Okay, now let's go up to the top and let's look and say, right, NH4 is a +1, NO3, right, all of these, they are together. The NH4 is an ion, the NO3 is an ion. So the NH4 is a +1, remember we saw how it was formed earlier. It comes along and it links onto an NO3, which is a -1, okay? So, and Ca is going to be +2, OH -1, so on this side, we're going to have to say, you are going to have to be 2 of you. Okay. That goes to ammonia, a salt, and water. So let's say this goes to ammonia, NH3, plus a salt, and water. Well, what salt do you think it is? Well, we said generally speaking, okay, the positive goes off with the negative there, and, oh, hang on, the negative, chances are it's calcium nitrate, okay? Well, let's have a look. CaNO3, okay, and water, okay? Now let's have a look. Remember, you can't start balancing yet because calcium is a +2, nitrate is a -1. So before you can start doing the major balance, you have to put in the balancing numbers as the subscripts. So that's going to have to be a 2. Okay. Now let's go back and now have a look. Okay. Well, here we go. NH3, NH4. In NO3s, there's 2 there. So straight away we know we're going to have to put in calcium. There's 1. 2 NO3s. So I'm going to have 2 NH4s there, aren't I? Okay. Just swap this over. Okay. So I'm going to have 2. Okay. Let me just go to red, sorry. Remember we said, hang on, calcium's balance, but my NO3 ion, there's 2 there, there's 1 there, so I have to put in a 2 there, right? Okay, now the next step is to say, okay, what's next? Calcium's balanced, I've balanced, but my amount, hang on, there's something weird here. What's going to happen here? Well, on this side, I've got 2 N's and I've got 8 H's, right? On this side, I've only got 1 N, right? So I need to put those. Remember, we're doing the nonmetals balancing now, huh? 2 N's. Forget the 8 H's. Now, the last thing we're going to do is we're going to look at this OH2. So on this side over here, we have got 2 O's and 2 H's. Can you see that that's balanced? The next is 10 H's and 2 O's, all right? So therefore, we put a 5 over there. Okay? All right? Let's have a look. Let's just check myself. 2. Oh, sorry. Okay, some of them do get a 5 H2O's, but not in this case. My bad. Sorry. I was busy on the ammonia. We've got 8 H's, but this side we've got 6. So there's 2 H's. Sorry. So we had 2 times 4 H, which is 8 of them that side, right? This side we've got 6 H's. So therefore, there's 2 H's over here. Okay? That can go to form the water, all right? Which essentially means that I've got 2 H's. There we go. There. But on this side, we've got another 2 H's. Okay? So we're going to have 4 H's because there's 2 H's coming from there. Right? And I'm going to have to balance that out now. Okay? So my last bit is to say, right, therefore, I've got 4 H's here and there's a 2 going in over there. Okay? And that's the end of that. Oh, no, it's not. Sorry, my bad. We've got over here, all right, the end of this one. Let's have a look at the next one. Okay? Is going to be, what was it? Hydrogen sulfide and sulfur dioxide. Hydrogen sulfide plus sulfur dioxide. Sulfur SO2. Sulfur and 2 oxygens. Right, so what do I have to do? Okay, I've already balanced that H2S and SO2. Okay, I've got that guy balanced as well. Right. Okay, what do I want to do now? I want to see what's going to happen. They say that this forms, okay, this forms here, sulfur, okay, and it goes to water. Sulfur and water like that, right? So H2S plus SO2 goes to that, okay? First of all, let's look. S is balanced over there, isn't it? Okay, no, but there's 2 S's. Here's an S, okay? Here's an S, and here's an S. So I've got to put in a 2 there, right? So now I've done that. Now I've got 2 O's and H2S. So basically, okay, I've got H2S, SO2, and yeah. Let's have a look here. 2 S's, that's balanced. H2, but my O2 isn't balanced. H2O2. Because it's not going to H2O2, it's going to H2O. So I'm now going to say, okay, but hold on. Let me balance my oxygens. Okay, I need to have 2 there. Okay, don't I? All right. I need to have 2 there. So now we've got 2, but now we've got 4. Okay, which means we're going to have a 2 in front of this one. Okay, to balance out the hydrogens. Which last of all means that we're going to have 2 S's and another S. So I'm going to have to alter that figure from a 2 to a 3. To a 3S like so, right? That's basically how we're going to have to balance that figure out over there like that. Okay. Now, the next pieces that they want is they want us to do, okay, question 13 is show the following dissolution reactions, okay, or ionization for aqueous, right? What do they want us to do? They want to say, okay, if this gets put into water, right, what happens? Okay, how do we deal with it if it gets put into water? Okay, what do? We say, right, sodium chloride solid plus water, NaCl solid plus H2O, right? How are we going to do this one? Okay, what do? We say in water, this is going to become an Na plus a Cl minus plus the water, correct? Okay, what happens now? Plus the water, okay? What we have to do is we have to show the reaction, how it works. The dissolution reactions result in the following aqueous ions, right? So now we've got the sodium, okay, going to Na plus chlorine aqueous in the water. There we have shown it, okay? What is the next one? Let's have a look at the next one that they want us to do, right? Okay. The next one is they want ammonium nitrate in water. Ammonium nitrate. So that's going to be NH4NO3, isn't it? Hang on. It's in words, so I've got to check my numbers. All right. +1, -1, and that's going to be going in water. So it's straight towards a dissolution reaction. What am I going to get? I'm going to get an NH4 plus an NO3 minus. Okay. Next one is going to be copper 2 sulfate. Here they've said copper 2, which means that is a +2, that's a -2. In water gives us Cu +2 ions plus SO4 -2 ions. And I know my writing is not great. Okay, that's what's happening, and that's copper. People do complain that my copper and my calcium look the same. So let me try. Doesn't help, does it? Copper and copper. Okay, that still looks like calcium. Okay, let's go and do it. Cu. Okay, +2. Okay, that's gone into the water. Calcium hydroxide is CaOH, but hold on. It's in words, so I've got to go +2 -1. So there's going to be, over here, there's going to be 2 of those, correct? Okay, so calcium and hydroxide, there's 2 of those because -2 +2. When that goes into water, okay, what do we get? Well, okay, technically, we're going to get, where am I? It's going to go into this Ca +2, and we're going to have 2 OH minuses, aren't we, in the water? So when we put that into water, we are going to have an OH, which means we're going to have a base in the water, correct? Okay. Now the next question is, show the following acids ionize in water, okay? Well, acids ionize in water, don't they? So let's see. Hydrochloric acid is HCl, correct? And when this ionizes in water, okay, HCl, we're going to have the H plus Cl minus ion, all right? Now the H, generally speaking, goes and adds onto water, calls the hydronium ion, H3O plus a Cl minus. This is your acid here, isn't it? This red guy, he's the acid. Okay? Can you see that the H3O and the H plus are the same? All that has happened here is what? Well, the H2O was coming along and it got an extra proton, same as ammonia did. Remember, NH3 got an extra proton, became NH4 plus. This is exactly the same. The proton came along and made H3O plus. Nitric acid is HNO3. Okay? That goes to what? Same thing. H plus, NO3 minus. The H plus is actually H3O plus NO3 minus. Okay? And the next one is sulfuric. What does sulfuric acid look like? H2SO4, correct? H2SO4, what do we do with that? It's going to go. But now, remember, it splits. So yes, there's an SO4. All right, just let's go back here and look. This is a -2. That was a +1. And we had to have 2 of them. So when it splits, the SO4 is going to go off on its thing there and goes aqueous. All of them go aqueous, right, in water. And what happens here? You get 2H plus aqueous, right? Which means you get 2 H3O pluses, aqueous, and plus SO4 aqueous. And if I just go back just to complete it, I should have in all cases over here put in aqueous, 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 like that. Okay? That's basically those, right? Now, the next one, okay, they are quite long, all right? So, because I went so way over the other, I'm going to cut this because the next are describe the tests, etc., and those require a lot of detail, which I won't get finished in the next period of time. So I'm going to cut this one short. And the next one we'll do is describe the tests and including the chemicals needed for the various bits and pieces. Very important part and usually quite a big hectic question. Cheers. See you later. Bye.